and welcome to using algebra to evaluate limits. The idea here is we're going to focus on rational functions. And we saw before that if the denominator went to 0, that could cause complications. So recall when working with rational functions, when working with rational functions, if the denominator went to 0 in our limit, so when we're working with rational functions, if the denominator went to 0, then we had some complications. We couldn't simply just divide our two limits. Right? So then we couldn't just plug in and evaluate. So what we will try to do is we will try to simplify our functions. So we will try to simplify the rational functions. So if we look at the limit as x goes to 2 of x squared minus 4 over x squared minus 7x plus 10, if we plug in x equals 2, then up top we would have 2 squared minus 4, and down below we would have 2 squared minus 7 times 2 plus 10. That numerator winds up being 0. The denominator also winds up being 0. And we run into our complication. We have this 0 over 0. We don't have any idea what that's going to do. So we are going to take in our old factoring technique. So we are going to factor. X squared minus 4 is a difference of squares. So we are looking at the limit as x approaches 2 of x plus 2 times x minus 2. Down on the bottom, x squared minus 7x plus 10. We have an x situation. We are trying to multiply two numbers to get a positive 10. So we will see. And then they should add to negative 7. So you can do x minus 2 and x minus 5. Now, at x equals 2, this is undefined. So at x equals 2, there's x plus 2 times x minus 2 over x minus 2 times x minus 5 is undefined. Oops. However, everywhere else, this is the same as just canceling out the x minus 2. So for x not equal to 2, everywhere but x equals 2, x plus 2 times x minus 2 over x minus 2 times x minus 5 is precisely the same thing as x plus 2 over x minus 5. And x minus 2 divided by x minus 2 is simply 1 as long as x is not 2 itself. So since with limits, we're not actually concerned about the point itself, we're just concerned with what's happening as we get close. We can go ahead and just swap the limit as x goes to 2 of x plus 2 times x minus 2 over x minus 2 times x minus 5. This is precisely the same thing as the limit as x goes to 2 of x plus 2 over x minus 5. Right? Again, the reason behind this, we have the limits are concerned with what is happening near our point. So what is happening close to, in this case, x equals 2, not what is happening precisely at x equals 2. So we call these, or these are essentially holes in the graph. The function does exactly what x plus 2 over x minus 5 does, except there's just a hole at x equals 2 where the function is undefined. So here we have a rational function. We're taking the limit, and the rule is that we can just go ahead and evaluate. So now if we try again, if we plug in x equals 2, then what we are looking at is 2 plus 2 over 2 minus 5, or a 4 over negative 3, or negative 4/3. So here we had another limit that looked to be going to 0 over 0, which causes complications. But we do know how to simplify and get this new value.